This is the last conservation of energy problem, and in this problem you have a hot dog vendor who is on top of one hill with his hot dog cart, and the cart gets pushed down that first hill, and when it goes down the first hill it goes all the way down to the bottom where it's got maximum speed and maximum kinetic energy. Then it loses some speed back up on top here, and it picks up and has a little bit more potential energy, but not as much as it did at the beginning. So in this problem what we need to do is figure out finally how fast is the cart going when this gentleman wakes up and sees it at the top of this hill. To do this problem we're going to use our conservation of energy equation again, and if you remember from before, the mass cancels out. So now we're left with 1/2 VO squared plus G times the original height plus 1/2 VF squared plus G times the final height. Notice that this one does have a final height. It's not 0, so be careful with this one. We're going to plug all our numbers in. We have 1/2 times 8 meters per second squared. That is the original speed of the cart at the top here. 10 meters per second squared is gravity, and 50 is the height of this first hill. The final speed is what we're trying to find out at this point, so we've got to use the 30 meters for that second hill. We go ahead and do some math. We squared the 8, took half of that. We added to that the 10 times 50, which would be 500. Here's our unknown, and then 10 times 30 would be the 300. At this point, we went ahead and added the 500 and the 32 on the left. We got 532 is equal to 1/2 VF squared plus 300 meters squared by second, or second squared. We subtracted 300 from both sides. You end up with 232 is equal to 1/2 VF squared. Multiply both sides by 2, and then finally take the square root of both sides, and we see that that hot dog cart is going about 21.5 meters per second on top of the second hill.